The next conic section that we're going to look at is an ellipse. So we know that if we cut a cone kind of in an angle, it's not a perfect circle, it's an oval, and it's a special oval called an ellipse. So let's look at what an ellipse looks like and how it can be graphed. For the ellipses that we're going to graph, they're either going to go horizontally like this, where they're longer in the horizontal direction, or we can graph them vertically like this, where they're longer in the vertical direction. So just like with circles, we have a center point right in the middle of our ellipse. So usually when I'm going to graph an ellipse, when I'm given an equation, I usually find that center point first. From there, what I do is I find this distance, this horizontal distance from the center to the vertex, or it could be from the center to the co-vertex, depending on if it goes horizontally or vertically. So then I find this A value, and then I find the B value going vertically. And then once you have those 4 points, then you can draw your ellipse on your graph. So let's talk about what these components are called. The longer length of this ellipse here, that's called the major axis. So if you notice when our ellipse is going horizontally, that major axis is a horizontal line. If our ellipse is in the vertical direction here, that major axis, that longer axis, is going vertically. And then we have the minor axis, which is the shorter one. The vertex, there's 2 vertices, and these 2 vertices are along that major axis. So if you notice on a horizontal ellipse, where our major axis is going horizontally, this point on the vertex is a vertex, and this point is a vertex. If you notice on the vertical one, since our major axis is going vertically, the vertices are not the left point and the right point. They're actually the top and the bottom points. The vertices are always on that longer major axis. And then we call the points on the minor axis the co-vertices. So we have 2 vertices and 2 co-vertices. And then if you watch the introductory YouTube video that I posted to the class, then you already know about these 2 points called foci, or some people say foci. I don't know the correct way to pronounce it. The teacher that I had when I learned this, they always said foci, so that's what I'm going to say. But a singular is just a focus. Foci is just plural for the word focus. So there's 2 of those. And if you notice, they're on that major axis as well, because in the horizontal one, the foci are here between the center and the vertex. And then here, since the vertices go up and down, the foci are still between the center and the vertex along that major axis. So there's 1 foci there, and 1 focus there, and 1 focus there. So if you're going to find the distance from the center to the focus, from here to here, that distance is a very familiar formula. It's just we have a minus instead of a plus like we usually do. So it's the square root of a squared minus b squared. And then, you know, the a is the distance between the center and the vertex, and the b is the center to the co-vertex in horizontal. If it's going vertically, the a value is the distance from the center to the co-vertex, and the b value is from the center to the vertex. I always just remember the a is the horizontal distance, and the b is always the vertical distance, regardless of whether it's vertices or co-vertices. It sounds pretty confusing. Also, if your ellipse is going vertically, you actually do b squared minus a squared here to avoid having a negative under the square root. It sounds a lot harder than it really is, so let's just look at some examples so you can see it with numbers and it'll make it a little bit easier. This is what the standard form of an ellipse looks like. So if you cover up the denominators, it looks almost exactly like the circle equation. So when we were looking for the center of a circle, we used the h and the k. Well, luckily for ellipses, it's the exact same thing. So we still use the h and the k to find the center of our ellipse. And then underneath the x, that horizontal distance, a squared is under here. So if you just take the square root of the number underneath here, that tells you the a distance. And we said that the a distance is this horizontal distance from the center to either the vertex or from this center to the co-vertex, depending on which way it's pointing. So you would take the square root of this number to find b, and b would tell you that vertical distance from the center to the co-vertex or from the center to the vertex. So that actually helps make it pretty easy. So I already have a few examples done, so I'm going to skip to one I haven't done yet. So we're going to look at this number 4 here. So just like with circles, the first thing that I do is I find the center. And I plot that first. So exactly the same thing that we did with circles. We take the opposite of the numbers that are inside the parentheses with the x and the y. So inside the parentheses with the x, we have a +1. So the x coordinate of our center is going to be a -1. There isn't a number being added or subtracted to the y. So that's y plus 0 or y minus 0. You're not adding or subtracting anything to that y, so the y coordinate of our center is 0. So this center point is at -1, 0. So you can go ahead and plot it right there. The next thing I do is I find a and b. Well, underneath the x squared is your a squared. So a squared is 36. And to get just a, you would square root that to get 6. So a is 6, and a is under the x, and we know x goes horizontally. So I'm going to count 6 spaces from the center to the left, and 6 spaces from the center to the right to get 2 of the points on my ellipse. Then I'm going to take the b squared, which is 9, and then find just b by square rooting. B is 3. B is underneath the y, so that's your horizontal or vertical distance, excuse me. You go vertically with y, up and down. So from the center point, we're going to count up 3. And we're going to count down 3 from the center point. And now we have the vertices and the co-vertices. So we can sketch in the ellipse. The only other thing that you need to be able to do is identify, well, which ones are the vertices and which ones are the co-vertices. So you have to look at where's the major axis and where's the minor axis. Okay, so the major axis is the longer one, so you can definitely see that this one's much longer because A is bigger than B here. So the major axis, we counted 6 in both directions, so that major axis is 12 units long. The minor axis, we counted 3 in both directions, so that's 3 and 3, which is 6 units long for the minor axis. So if you remember at the beginning of the video when we were talking about vertices and co-vertices, the major axis, the longer one, that's where the vertices are. So the vertices are the points here and here. So this one is at -7, 0, and this other vertex is at 5, 0. So then we know that the co-vertices are the 2 points along that minor axis. So this point here is at -1, 3, and this co-vertex is at -1, -3. So you should be able to look at the graph and just write down the order pairs of those vertices and co-vertices. The last thing that you need to be able to find are the foci. We need to find both of the two focus. So in order to find those, that was this little formula here. Usually they use the letter C a lot of times for the focus. So if it's going horizontally like this, we're going to do the square root of a squared minus b squared. And that'll tell us what C is. So C is the square root of A squared was 36 minus B squared was 9. So 36 minus 9 is 27. So the square root of 27, I'm going to type that in. That is about 5.2 if we round it. Okay, so that doesn't tell us the order pair of the foci. This C value, this tells us the distance from the center point to the focus. So that's telling us how far away these are. So you can see that since the foci are along this major axis, 5.2 spaces from here is where the focus is going to be located. So we're going to start from this center point, 1, 2, 3, 4, 5.2. There's one of the foci right there. And then you can count 5.2 this way. 1, 2, 3, 4, 5.2 this way. So that's the easiest way to graph them. And then you actually need to write down the two order pairs for the foci as well. So if you notice, the y values didn't change. They're both all along that major axis, which all happen to have a y equals 0 right there. So we all know that the y values are going to stay 0 for these foci. So all we have to do is take this center point, and we just added 5.2 to that -1. So -1 plus 5.2, well, you can see on the graph that's at 4.2. And then if we're at -1 and we subtract 5.2, now you can see on the graph, now we're at -6.2. So on the note sheet, it looks pretty confusing, doesn't it? But it's actually pretty easy. You take the x-coordinate from the center and add that value C to it. And then for the second order pair, you just subtract that C value from the x-coordinate. If you notice, the y-coordinates stayed the same. So that center point had a 0 for the y, so we kept both of the y's 0. The x-coordinate, -1, is what we added the 5.2 to. -1 plus 5.2 gave us the 4.2. Then we took this -1 and subtracted 5.2 to get the -6.2. So that's how you identify all of the fun characteristics and graph an ellipse. I want to go ahead and do an ellipse that is going vertically this time. So in this example, we can find our center the same way we did with our circles. We can take the h and the k. So the opposite of a -3 is a +3. And then y doesn't have anything being added or subtracted to it. So again, the y-coordinate is going to be 0. No, it's not always 0. It just happens that both of these examples have 0 for the y-coordinate. So the center is at +3, 0. So it's going to be right there. Then we said that a squared is always underneath the x and the b squared is always underneath the y. So if a squared is 9, square root that, we know that a equals 3. So we always said that a is under the x because x is horizontally. So we're going to count horizontally 3 spaces to the left and 3 spaces to the right to get 2 of the 4 points on our ellipse. Then we'll use the b squared. We have that b squared is 49. So if you square root that, you get b equals 7. So in the vertical direction, because that's underneath the y's go vertically, we count 7 up to get a point on the ellipse, and we'll count 7 down to get our 4th point on the ellipse. Once you have those 4 points, the 2 vertices and the 2 co-vertices, then you can try to draw your ellipse in here as pretty as you can. I am definitely not an artist, but I try my best. So that's what our ellipse looks like. So then we can identify our vertices and our co-vertices. So The vertices, we said, were always along the major axis. If you notice, the major axis is going vertically this time. This is much longer than this horizontal axis here. So our vertices are this top point here, which is at 3, 7. And it's at this bottom point here, which is at 3, -7. And then the co-vertices, they are at 0, 0, and what is that, 6, 0? Because the co-vertices are always along that shorter minor axis. The only other thing we need to make sure that we know how to find are the foci. So in order to figure out where they are, we need to figure out what C is, which is the distance from the center point to the foci. So this is where we do the square root of b squared minus a squared. Because b squared is bigger than a squared this time, so we want it to go first. So the square root of the 49 minus the 9, which is the square root of 40. So if I type that in real quick to get an estimate, it's about 6.3. So since this is going vertically this time, we want to actually add our value for C to the y coordinate of the center this time, because we need our foci to be along this major axis. So the 3, the x, is going to stay the same for our foci. It's the y coordinate that's going to change. We're going to add 6.3 to 0, which is 6.3. So 0, 6.3 is one of the foci. And then we're going to take 0 minus 6.3 to get the other foci, which is at a negative 6.3. So at 3, negative 6.3, we have our other foci.